Hello all, good afternoon to one and everyone present here. So we are a team data science wizards, highly skilled in artificial intelligence in the data science space. We've also worked in the past with environmental data and with air quality that has piqued our interest to be here at the hackathon today. Sorry, can you change the slide, please? Yeah. So this is just a quote that we have. So the air we breathe is a shared resource, and the impact of it on climate change is also a shared problem that hence requires a shared solution. So tackling this, we've devised for a deep tech-based solution that essentially is used based on a predictive model that will help in improvising the air quality. The main causes for nitrogen or air pollution or poor air quality is generally targeted with travel emissions and with respect to construction. And the impacts of it are, of course, something like global warming, and of course, we have the poor health and also industrial-based problems. So moving on. You can
okay. Great, thank you, Rahul. So we churned both the data that we have received, the descriptive data basically, and the per second data, and we came up with we entire followed the life cycle of analytics, started with the descriptive analytics that helps us to find the correlation between the important pollutants, followed by what exactly the distribution look like, because we wanted to go from the descriptive analytics to the predictive analytics and give some prescription on top of that. So this is one of the very important aspect we saw that while working on the descriptive analytics in a particular areas. When a vehicle moving within the speed of like 10 to 15, they are emitting more pollution as compared to when they are going with like 30 to 60, something like that. So you can see a peak when it is close to 15, and the peak is going down exactly when something between 30 to 50. This is the k-means clustering algorithm that we have worked upon that has given us the clusters where exactly the red areas are, where is green area, and where is the amber areas. And based on that, we came up with this final chart that can help you to identify, given the name of the area, what exactly the risk level of each of this pollutant is. Like, what is the risk level of NO2, what is the of CO2, and so on. So we have created one small demo as well where you can, it's just Angular-based demo where you just upload the data. Yeah. So this is based on the predicted areas that we had. The model predicted that in certain areas of Dublin, the NO2 or the PM2.5, the emission is going to be really high. It will show you the same area in the map as well, where it is predicting that it is going to be high. And in the same way, it goes for the NO2 as well, where the area is really high for the NO2 as well. It shows you that in red, and the same followed by in the green as well. So this is for the PM2.5, we can see. And the same again, like one of the areas in Dublin where it will show for NO2, it was initially in red and then followed by the green. So basically, this areas has been predicted by our model, which is predicting correctly as compared to what data we have received. We have validated it with the same. Yep, I think that's it. Thank you, guys.